Hello students, welcome to my YouTube channel. In this video lecture, we are going to continue solving the next questions from Keith Williams' GenMath book. The topic name is Great Circles. Very important from the point of view of your CPL, ATPL and airline exams. So let's start with question number 51. On a polar stereographic chart, the initial great circle goes from point A, which is 70° north, 60° west, towards point B, which is 70° north, 60° east, is approximately what? So now we are in the northern hemisphere. So let's draw this representation of the polar stereographic projection with respect to the north pole. With respect to the north pole. So let's say this is your north pole. Okay. Both are located on the same latitude, 70. 70° north, 60 west. So this is your prime meridian, 60 west, 60 east. Okay. So from A, you're traveling from west to east. You're traveling from west to east. So what is the uh, great circle course? Now, great circle tracks on polar stereographic projection bend towards the pole of projection. That means they are convex towards the pole of projection. Here the pole of projection is the north pole. So your great circle track will be somewhat like this. It will be approximately a straight line, but still bending towards the north pole. Now, first things first, your line track at 60 west is point A. So your line track at point A is what? It is 090. Both locations are located on the same latitude. You're flying from western hemisphere to eastern hemisphere. So when you fly from west direction to east direction, you fly a track of 090 east. So drumline track at A is 090. So this complete angle, big angle is 090. So the great circle track next. Great circle track at A will be drumline track at A minus the convergency angle. So this great circle will be this big angle, drumline angle, minus this small inside angle, which is your convergency angle. The convergency here is B long, 60 west, 60 east, 120 degree, sine of 70. Sine 70 into 120 is 112 degree, 45 minutes. So convergency angle is half of that, which is 56 degree, 22 minutes, or approximately 56 degrees. Okay. So 2090 minus 56 degree is what? So minus 90 is 33 degree, or 90 minus 56, 34 degrees. Okay, so great circle track at A will be 034 degrees. Next, 52. A straight line on a Lambert's chart for normal flight planning purposes is approximately a great circle, is approximately a loxodrome. A rum line can only be a parallel of latitude. So rum lines, a different name for rum line is loxodrome. So Bravo and Charlie will be wrong. Can only be a parallel of latitude, wrong. Option A. So remember your polar correction, your Lambert's conformal chart. This is your north pole, let's say. So all meridians will be straight lines. All meridians will be straight lines originating from the North Pole. And we all know that meridians are nothing but great circles. Meridians along with the anti-meridians form a great circle. right? So that's why option A is the right answer. On a Lambert's conformal chart, straight line can be approximately a great circle. 53. On a direct Mercator chart, rhumb lines are, remember, straight lines. Rhumb lines are straight lines. Which one of the following describes the appearance of rhumb lines except meridians on a polar stereographic chart? So just now we saw in the question number 1, first question we did in this lecture, that rhumb lines on polar stereographic projections are lines which are concave, that means bend away, concave to the pole of projection. Okay, concave to the pole of projection. Next. On a Lambert's chart, standard parallels are 37 north and 65 north. So let's say this is your Lambert's chart, 37 north and 65 north. And there is a straight line, you are drawing a straight line between 49-degree north and 48-degree north. Point A is here, point B is here. Point A is 49 north, 30 west. So 49 north, 30 west. Point B is 48 north, 40 west. 48 north will be below 49 north, so somewhere here. And 40 west means to the west of 30 west longitude. So, okay, so you are flying from A to B, like this. Now, these are the two standard parallels, 65 north and 37 north. The average is 51 north. That average 51 north will be your parallel of origin. Now this 51 north will be above this 49-degree north latitude as well as 48-degree north latitude. So what I will do is I will erase this, and first I will draw this parallel of origin, the average parallel of origin, which is 51-degree north. Now I will draw the 2 points, point A here, point B here. Now always remember, on Lambert's chart, the great circle will be a curve concave to the parallel of origin. Concave means it will be bending away from the parallel of origin. So the great circle here will be somewhat like this. Okay, it will bend away from the parallel of origin. So great circle and rhumb line are to the south. So great circle and rhumb line are to the north. Great circle is to the north, rhumb line is to the south. Rhumb line is to the north, the great circle is to the south. So you can see this is your parallel of origin. Both rhumb line and great circle are to the south of it, are below it. So the correct answer will be option alpha. Next. On a polar stereographic projection, south pole. Now it's the south projection. A straight line joining 75 south, 75 south, 65 east and 25 west. It is not 625, it is 025 west. The true course on departure from position A is what? So let's draw this projection. This is your south pole. This is your prime meridian. Point A, 65 east. And this is 25 west. Great circle will be towards the nearest pole of projection, that is south pole. So we have to find out the true course on departure from position A. Now position A is 65 east. Now you are going from eastern location. to the western location, right? So when you're traveling from east to west, you will be flying a direction of 270 since both locations are on the same latitude. Okay, so Rumline track at point A is equal to 0, 0. Great circle track at point A will be Rumline track plus the convergency angle. So 0, 0 plus convergency angle. Why plus? Because great circle is this. This is your Rumline. Great circle is more than that. Okay. The convergency angle here is what? Convergency is D long 65 east plus 25 west 90 degree into sine 75 86 degree 55 minutes or approximately 87 degree. So convergency angle will be half of that 43 degree. Okay, 27 minutes, so 43. So 090 plus 43 is 133. So great circle track at A is 133.